Hello there, and thank you so much for joining me for this video. So in this video, I'm going to go through another example of how to conduct independent t-tests. So you guys might recognize, hopefully, this problem from, I believe, homework 3. So we talked about a study investigating whether kids who wore Halloween masks took more candy than kids who did not wear masks. And presumably the Diner et al. Sort of theory with respect to this question was that masks increase anonymity and therefore they might increase the children's propensity for antisocial behavior, right? And fortunately, you guys already did this problem. And when you did, you noted the sample size, which was 8 children per group. And you calculated the sample means. Again, notice the italics there for the M notation. And they were 3.63 for kids with masks and 2 for kids without masks. And the standard deviations were 1.85 and 1.20, right? So it appears at first blush that the hypotheses, Diner et al., the hypothesis seems to be correct, right? Because the mean number of candies taken is much higher in the kids with masks group than the kids without masks group, right? But in order to determine whether this difference is statistically significant, we need to conduct an independent sample t-test, right? And why are we doing that? Well, we have our independent variable is a categorical variable with 2 levels. So we have presumably anonymity is our independent variable. So we have kids with mask and kids without mask. Those are our 2 levels. And then we have a continuous variable, which is a continuous variable on a ratio scale, which is simply the number of pieces of candy taken, right? So it's inherently quantitative. Okay, so we have one categorical independent variable with 2 levels and one continuous dependent variable. So we know we have to conduct a independent samples t-test. And just to remind you of the components of the formula, up top we have our observed difference between our groups. So we have the mean of group 1, and again, group 1, whatever group you refer to as group 1, it really doesn't matter. So it could be kids with masks or kids without masks. So we'll say kids with masks is group 1. Okay, so the difference between the sample mean for kids with masks minus the sample mean for kids without masks, that's what we're doing at the top of the fraction. And then DF1 and DF2 are simply the degrees of freedom for each of our groups. And we calculate that by the simple formula of just n minus 1. And then SD squared 1, SD squared 2 is just the squared standard deviation of group 1 and group 2, respectively. And then over on the right, we have N1 plus N2 and over N1 times N2, which is just the sample size of group 1 and group 2. Okay? So again, what this equation represents is the observed difference on top over the difference we would expect by random chance alone or the standard error. Okay, so let's go ahead and plug in our values, right? So we have 3.63 minus 2 for our observed difference. We have the sample size of group 1 minus 1, which is the degrees of freedom, times the standard deviation of group 1 squared, plus, again, the sample size minus 1, which is 7, times the standard deviation of group 2 squared, over 7 plus 7, which is the degrees of freedom of group 1 plus the degrees of freedom of group 2. And then finally on the right, we have the sample size added in the top part of the equation and multiplied in the bottom part, right? So at first blush, this equation looks very intimidating, but it's actually quite simple once you know what the values in the equation correspond to, or what the notation in the equation corresponds to. All right, so let's go ahead and state our hypotheses. Remember, the null hypothesis is always that there is no difference between the groups, or that the means in each group are equal to each other, right? So the average number of pieces of candy taken by masked and unmasked children is equal. Whereas the alternative hypothesis, which is also a directional hypothesis, right, is the average number of pieces of candy taken by masked children will be higher than that of unmasked children, right? So children who are masked will take more pieces of candy than unmasked children will, right? Okay. So again, we're just plugging into our formula. So I went ahead and did some of the math for you. Okay. And again, we're just on each slide, I'm showing you sort of the process of doing that calculation. All right, and if you do the calculation correctly, and again, I would encourage you to look over these slides on Canvas and kind of go slide by slide as you're plugging these numbers in. And again, make use of a calculator, a good calculator that makes it easy to punch in a bunch of numbers. And hopefully you will get the same t-value that I got, but if you don't, you're more than welcome to contact me with questions, okay? So if we plug in all those numbers kind of step by step, what we end up with is 2.09 as our obtained value. Okay, so now that we know that t is equal to 2.09, we need to find our critical value. So we're going to calculate degrees of freedom, which is again n1 plus n2 minus 2, or sample size of group 1 plus sample size of group 2 minus 2. Okay, so if we do that, if we add up 8 plus 8, which is the respective sample sizes of group 1 and group 2, we get 16 minus 2 is 14. Okay, so if we select 14 as our degrees of freedom, and again, because we have a directional hypothesis, we go all the way to the last column, we see that our critical value is 1.761. Okay, so once again, our t-value is 2.09, which is bigger than 1.761. Therefore, once again, we can reject the null hypothesis and conclude that there is a relationship between anonymity and candy consumption, right? So masked children take significantly more candy than unmasked children. Okay, so our last step is to write up our APA style paragraph. So again, we start with our hypotheses. So we hypothesize that masked children would take more candy than unmasked children. And then we evaluate our results in terms of our hypothesis, right? And so because our hypothesis was correct, we would say consistent with this hypothesis. So consistent with this hypothesis, and then we identify the type of tests that we conducted. So consistent with this hypothesis, an independent t-test showed that the average number of pieces taken by masked children, right? So there we would report our mean and standard deviation for group 1, was higher than the average number of pieces taken by unmasked children. So again, we report the mean and standard deviation of group 2. And lastly, we report our t-value with our degrees of freedom in parentheses, our obtained t-statistic after the equal sign, and whether our p-value is greater than or less than 0.05. In this case, because our critical value was 1.706, or I think that was correct, 1.706, and that is less than the critical value, then we know that p is less than 0.05, and we can reject the null hypothesis. Okay? So again, anytime you write a AP-style paragraph, you're going to state your hypotheses, and then you're going to indicate what type of statistical test you conducted, and then you're going to report your descriptive statistics, which when your outcome variable is a continuous variable, you report your mean and standard deviation. And then lastly, you report your obtained statistic, your degrees of freedom, and your p-value. And again, note that all of the notation is in italices. M is in italices, standard deviation is in italices, T is in italices, and P is in italices. Okay, so I went through that a little bit quickly, especially the various stages of plugging the numbers in. So certainly if you have any questions or if you're coming up with a different value, feel free to chat with me during office hours or in our clarification meeting, and I can go through the equation with you. All right, guys, have a great day, and I look forward to seeing you in my next video.